Hello and welcome to T2 Day 27 of Honors Precalculus. We will continue working with polar functions, and we're really going to lean into using our calculators as well as powerfully using algebra. So first note, whenever you see converge, we can just change this to Desmos. This is the updated wonderful program we're going to use to graph things online. Also, we also have our wonderful calculators too. So when you graph these on a calculator, you're literally going to be typing this function right here into your graphing calculator, but just make sure you're in the polar graphing mode, and then choose the appropriate window. You need to practice this, and we will continue practicing it in class. You know, much of the time what's going to happen is you'll notice that the theta value goes from 0 to 2 pi. So you'll know that you need to set theta between 0 and 2 pi. That's kind of a good Zoom standard. And then you can also use tables to get R values. But what's going on here is you're plugging in a theta value and you're getting out a radius. So what that means is as you graph these, you're going to plug in, let's say 0 degrees. And where do you stop? This function tells you where the point is going to get plotted. So then let's say the next one was pi over 6. Where's the next one? So this one might look like this. But the idea is the input is a theta and the output is an R. You can use your calculator or Desmos to graph these. You should practice these. So you have a whole list here for sine theta, for sine 2 theta, for tangent theta, and start playing around and seeing what these look like. Play around with getting proper windows. It's very important. But what we need to look at next is what we're going to deal with in terms of algebra. Here are some key things you need to remember. First, if you're going from from polar to rectangular, x is equal to r cosine theta, y is equal to r sine theta, theta is equal to tangent of y over x if you have the y and the x, if you have x and the y, and r is equal to x squared plus y squared. Remember, we get that from these triangles here. So if this point right here is xy right there, this length is the square root of x squared plus y squared, and theta right here, tangent of theta is equal to y over x, y over x. So theta is equal to tan inverse of y over x. And then you also know that cosine of theta, also this is r, right? That would be that distance. So it's r comma theta right here. Cosine of theta is the adjacent side over the hypotenuse. That tells you right there, that x is equal to r cosine theta. And similarly, it also tells you that y is equal to r sine theta. So again, that's where they come from. It's important to know that. So we're going to convert the following from polar to rectangular form. So how are we going to do that? We're converting functions here. So first of all, we need to remember that secant of theta is equal to 1 over cosine theta. That's just the definition of our trig functions. So now we know that r is equal to 4 times 1 over cosine theta. Multiply both sides by cosine, and what do you get? You get r cosine theta is equal to 4. R cosine theta is equal to 4. But this is the definition of x. R cosine theta is defined as x. So this function is just x equals 4, which is in fact a vertical line at x equals 4, which is pretty cool. So this right here is a vertical line at x equals 4. I found that pretty neat. You can turn trig functions into vertical lines. Over here, not much has changed, but it's going to graph something very, very different. And this is just going to take practice. So I'm going to show you the quickest way that I know of to go about this. Well, the first thing we know is that r is equal to x squared plus y squared square rooted. And cosine of theta, for cosine of theta. Let's try to replace that with something. Cosine of theta, what we know, we have this theta value, and we know it has some x and y value right there, and we know that this is x squared plus y squared. So what that tells us, we know that theta from the definition I showed you before is tan inverse of y over x. Theta is tan inverse of y over x. This looks like it's going to make it worse. Well, have faith. It does for a second. So what you end up with is for cosine, and instead of theta, we have tan inverse of y over x. Now, that should make you feel a little bit nervous. Tan inverse of y over x, tan inverse of y over x. What is tan inverse of y over x? What is tan inverse of y over x? Remember, this just represents an angle. That just represents an angle. So what triangle has that angle? What triangle has tan inverse of y over x? Well, it's this triangle right here. So what is the cosine of this triangle right there at theta? It is going to be x over the square root of x squared plus y squared. So what that means is you can replace the tan inverse right there with this. So what you end up with is actually the cosine of the whole thing is that. So the cosine of this theta right there, the cosine of that theta is x over the square root of that. So what do you end up with? You end up with the square root of x squared plus y squared is equal to 4 times x over the square root of x squared plus y squared. I want to say that one more time. When you have theta here, you know it's some x, y right there. So one way to say theta is tan inverse of y over x, but then what is the cosine of this triangle right here at theta? The cosine of that angle value is going to be this right here. So what do we do now? We multiply both sides by the square root of x squared plus y squared, and then we get x squared plus y squared is equal to 4x, because it cancels on the right-hand side. What do we do now? Well, x squared minus 4x plus y squared is equal to 0. All I've done is move that to the left side. And now I'm going to do something magical called completing the square, where I'm going to add 4 to both sides. And the reason I got that is half of this value squared is 4. The reason we do that is this right here, you might remember, turns into x minus 2 squared, and you end up with this. And this is a circle of radius 2 centered at 2, 0. So this is how you can turn seemingly very similar polar form equations into rectangular forms. This is a vertical line at x equals 4, and this right here is actually a circle of radius 2 centered at 2, 0. So how do we go about converting from rectangular to polar form? Well, one thing we know is that x is equal to r cosine theta, and y is equal to r sine theta, so it's just substitution. So you get r cosine theta plus 4 times r sine theta equals 5. So then you get negative 2r cosine theta. You can just get rid of the parentheses, 4r sine theta. That equals 5. What can you factor out of both of these? You need to isolate r, because it's r in terms of theta. You get r times negative 2 cosine theta plus 4 sine theta equals 5. So what does this equal? R is equal to 5 over this entire thing. Now that looks big, but you can now plug that in polar form and graph this. Just takes practice. The big things to remember really are these rules right here, and then to play around with them. And then lastly, please make sure you go and type these into your calculator and Desmos to see what they look like.